Hi, good afternoon. Hope all of you are joined. So today we are going to discuss different laboratory equipments and different materials being used in laboratory for different purposes. So let me start with Eppendorf tube. Okay. So you can see that there are different types of Eppendorf tubes which are being used in the laboratory. So you can see one tube like this. You can see the bottom. This is pointed or conical bottom. So 1.5 ml Eppendorf tube. Of course, 0.5 ml tubes are there, smaller in size. And then you can also see that there is 2 ml Eppendorf tube, 1.5 ml and 2 ml. Difference is the bottom you can see here. This is something conical and this is in the bottom if you see, this is round bottom. Okay, so if little bit thing is there, they will go and stick in this bottom. If you try to mix it, mixing will be a bit difficult. So for pelleting, it is easier, but for mixing, if you want to mix something, this will be easier so that you can close the tube like that, and then by doing this, you can mix it very well. But that sort of mixing in case of this tube will be little bit difficult because this is conical type of bottle. So these tubes have been named Eppendorf tubes after the name of the scientist whose name was Eppendorf. So on his name only these tubes are called Eppendorf tubes. So I said there are other tubes smaller in size, and that is 0.5 ml tubes. And then you can also see that this tube, this is still smaller, and capacity of this tube is 200 microliter. So this also looks like 1.5 ml but smaller in size. So 0.2 or you can say 200 microliter. This is 1500 microliter, and size wise in between 500 microliter tubes you can also see. So it will be bigger than this but smaller than this. So this tube 100 or this is 100 microliter, or this type of a smaller tube is called PCR tubes. And of course, if you compare wall of this tube, this is thick wall and this is very thin wall tube. Okay, 100 microliter capacity. So this tube is also known as PCR tubes. So whenever you are doing PCR, then we are using this tube, a small size tube, thin wall tube, so that when heating or cooling is there, quickly the solution inside or reaction mixture inside this tube will be quickly heated up or cooled down. That is why thin wall, a smaller in size tube. So that is why this is called PCR tubes. Okay, so for keeping these tubes while working with these tubes, you have to keep somewhere. So this is called rack, Eppendorf tube rack. So that you can keep things like this. You can keep it here in this rack. So many tubes can be kept here, and you can work. The two lanes are there, so you can keep and work easily. There are different sort of these racks, different types of rack. So you can see this is also looking like some rack, but like this you can keep your tubes here. But this is not the actually rack. This is float. Whenever you are using water bath, if you put in the water bath, this will be floating, and this will allow the tubes working as a stand, but more than a stand, this is a float. So holding all of your tubes and floating in the water bath. So these tubes are not going to dip inside the water bath. So this is float. Okay. Then there are different types of tubes again. So screw cap tubes, you can see this one. This is 50 ml tubes. This is still thinner, 15 ml tubes. So depending on the experiments or requirements, and then labeling is there, marking is there. So roughly you can see how much solution. Suppose 5 ml solution you have to take. So you can see the 5 ml marking, and then final marking is also made. So accordingly you can roughly you can take the solution in this based on this marking. Otherwise, if you have to add something like when you are making PCR mix, then you have to use pipettes. So I was showing last time pipettes. Using these pipettes, you will be adding solution here. Maybe 1.5 microliter, maybe 2 microliter, 5 microliter, 10 microliter, or something like that. So this particular pipette is for, this is 2.5 microliter pipette. So zero point 0.1 microliter to 2.5 microliter can be measured using this pipette. Okay. So you can see here readings are there. You have to adjust reading. You see reading is changing. So I am moving this one and reading is changing. So depending on whatever is the requirement, you can change or you can increase the reading. So like that you can do and adjust the reading. Say for example, I want 3.2. So you can see the reading here, then you can adjust. Or if I want 3.5, so 3.5 microliter. No, sorry. This is not 3.5. This pipette itself is 2.5. So you can see here 2.3. Yeah, this 2 and this 3. So like that you can adjust. Of course, 5 microliter, 10 microliter, different pipettes are there. So you just don't see what is the reading here. You have to see what is the pipette. You can see it is written here the capacity of pipette. You can see that it is written 0.1 to 2.5 micron. So first you have to see this one. And then only you can know that what is the reading here, what does it mean. Say for example, another pipette. Okay, and here you can see again what for this pipette is. So you can see here that it is zero point 0.5 to 5 ml. Okay, so first you have to see that what is the capacity of this pipette. So you have to see that this pipette is for zero point 0.5 to 5 ml. So microliter you cannot measure. You have to measure in ml. 1000 microliter is equal to 1 ml. So maybe 0.5 ml or maybe 1 ml, 2.5 ml, 3 ml, up to 5 ml if you have to measure. Roughly you can measure. Of course, you can use pipettes also, that glass pipettes, and using that you can do that experiment. So for this 5 ml, if you have to take 5 ml, then see the tips size, bigger tips will be there, and you can put like this. You can adjust that reading and you can take that. Okay. So similarly, for different like this is 5 ml pipette. So similarly 1 ml pipette is there, 200 micro or 1000 microliter pipette, 200 microliter pipette, 150, 250. So different types of pipettes are there. Whatever is available with you and whatever amount you want to measure, you have to accordingly select the pipette, and you have to select the tips also. You come. सर मैं नंबर चल रही है हाँ अभी अभी कुछ नहीं अभी so this is the tips which can be used for 1 ml. If you are using 1 ml pipette, so blue tips and blue tip box. This is the tip box. So you can arrange tips here in all these holes. Tips are there. So of course this is uh, 5 ml pipette, but just I will try to show you like that. You have to put the pipette tips here and take the tips. So whenever you are using 1 ml pipette, you have to use blue tips, and this is the tips box from tip box. And generally, we fill the tips here, autoclave it so that the tips should be sterile. If you are using 200 microliter pipette, so you should know that which pipette fits with which tips. So generally 1 ml pipette or 1000 microliter pipette, blue tips is used, and 20 microliter, 200 microliter, yellow tips are used. So this is yellow tip box, and then you can see there are tips here, so many tips kept here, and you can just pick one tip and you can do it. So after filling it, we used to autoclave it, sterilize it. So whatever contamination or other things are there, they should be removed. So you have to be very, very careful which pipette will fit with which tips. And fitting of pipette and tips should be very tight fitting. Otherwise, leakage will be there, and suction is based on the creation of vacuum and sucking. So if leakage is there, or you can see the tips is not well fitted with the pipettes, then leakage will be there and suction will not be there. So instead of sucking, suppose you want to suck 150 microliter and your tips are not fitting well with the pipette, so only 50 microliter will be sucked, or 100 microliter will be sucked, but it will not be exactly 150 microliter. So you have to be very, very careful about the tips. So similarly, if we are going to use this pipette, like 0.5 microliter, 2.5, 2 microliter or 2.5 microliter or maybe 1 microliter pipette, then micro tips should be used. And you can see these are the micro tips. Okay, so these are again filled with tips and autoclave. So you have to put your tips, and now you see. So you have to just tap here and tip is coming out. Okay. So to be very sure that this is fitting properly, you just put like this and tighten it, and then now you can handle it. Okay. So if I try to just try to see that this pipette requires micro pipette tips, these tips. Okay. And by mistake, if I am doing like this is 2 microliter, or you can say 2.5 microliter pipette requires micro tips, but I am trying to use this yellow tips here. So what will happen? I will put here, no, the tips is not coming. Tip is still there because it is not fitting. Okay, so you have to ensure that tips and pipettes, they are fitting very well, otherwise you cannot use them. So similarly, for this 5 ml pipette, you cannot use 1 ml tips. And even if you are somehow you are trying to fit it, then this capacity of tip itself is 1 ml. So how can you take maybe 2.5 ml or something like that? So we require bigger tips. So bigger tips, and then easily you can take 5 ml. So again, this can be put in tip box. So you have to put like this and then tighten it. So tightening is necessary, otherwise there will be leakage and proper sucking will not be there. So I was telling about another Eppendorf tube. No, you can see this is 0.5 ml or 500 microliter. Eppendorf tubes. Okay, so generally what we used to do, we put in a bottle. hmm, These Eppendorf tubes are placed there, and then close it and autoclave it so that the tubes will be sterilized. So one more different types of tips you can see is this one. You can see here again this bottle, all the tips are kept there and then autoclaved so that it will be sterilized. And what is difference between this tip, sorry, this Eppendorf tube and this Eppendorf tube? You can see if I open it, what is the difference? This is transparent. Okay, you can see inside what is the solution is there or not. This is totally black. Okay, not transparent, opaque tubes, Eppendorf tubes. So those reagents or those chemicals which are light sensitive should be taken in this type of Eppendorf tubes. So you have to be careful that whatever reactions you are going to make, so if they are light sensitive, then you have to keep away from light. So for keeping them away from light, you don't need to use this one. If you are using this one, light will go inside and they will react with light, or some reaction will be there. If you keep inside this, there is no entry of light, and so light sensitive reactions can be made or should be made using this type of Eppendorf tubes. It means there are certain chemicals which are, or certain reagents which are sensitive to light. So similarly, if you find that there are certain reagents which should not get in contact of some solutions or some chemicals which should not be exposed directly to light, then you should use this type of bottle. What is type of the bottle? Amber color bottle. So this is not transparent or uh, clear bottle. This is amber color bottle. So you can see this is bigger in size, this is smaller in size, this is 100 ml bottle, and this is 500 ml bottle, but both are amber color bottle. Okay. So similarly, you can see these are transparent bottle. Those solutions which are, or reagents which are not sensitive to light, can be kept in a smaller bottle, transparent bottle, or bigger bottle depending on the requirement. This is 500 ml bottle. You can see 100, 200, 300, up to 400 marking is there, and here also you can see marking is there. So roughly you can have idea how much solution is left. That is why this marking is there. This is not for the measurement, just to have idea that yes, I have 100 ml, 200 ml, or 250 ml, roughly 250 ml solution is left. So I should make, if I require 300 ml, then this may not be sufficient, I should make fresh. If I require just 100 ml, then this is more than sufficient, my work can be done with the remaining solution. So for having rough idea, these marking are there. These are not for measuring. Measuring so that marking is not for measuring the reagents. So for making measurements, measuring, we have measuring cylinders, something like this. So this measuring cylinder is 1 liter. So similarly, a smaller size measuring cylinders are also there. So you should use measuring cylinder to make up the volume, or roughly, again rough. If you want to exactly measure the volume, then you have to go to pipettes or micro pipettes, something like that. But rough measurement, but better measurement than this, then you have to use measuring cylinder of different size. Say for example, if you want 60 ml solution, will you use this 1 liter measuring cylinder? You should not, because 60 ml can be measured here, but again accuracy will not be that much. So for making 60 ml volume, you should use 100 ml measuring cylinder. So this is 1000 ml. Similarly, half a liter measuring cylinder is there, 100 ml measuring cylinder is there, even 25 ml measuring cylinder is there. So depending on the requirement, what is the requirement, what is the volume you want to make up. So accordingly you will be selecting the measuring cylinder and you will measure the volume. So chemicals also comes like that. You have to see what type of chemicals you require. So that chemical should be there. Chemical formula is there. Molecular weight is there, and of course which company. Hmm? And then sometime you may need molecular biology grade. So what purpose? What is the requirement? For what purpose you want the chemical? So accordingly you have to select chemical and chemical company. So if you want sometime molecular biology grade and very high quality of chemical, then generally we go for sigma chemicals. But for preparing media and other things, not that much molecular biology not involved, then SRL type of chemicals. So normal chemicals can be used. Okay, so in this bottle you can see what is the calcium chloride, what is the purity, which company, molecular weight. So sometimes you require to make 2 molar solution or maybe zero point 0.5 molar solution. So you will need what is the molecular weight. So what is the molecular weight and how to prepare 1 molar solution or zero point 0.5 molar solution or maybe 5 molar solution. So you have to make calculations and accordingly you can make the solution. So if the chemical is hazardous, then material safety data sheet is also available. So you have to read, and there are certain chemicals like this. This is calcium chloride, and you might be aware or you may not be aware. Sodium chloride, calcium chloride, ammonium chloride. So these are the solutions which are these are the chemicals which are hygroscopic in nature. Means if you open this box and keep it loosely tightened, it's not well tightened, then it will absorb moisture from the atmosphere. And right now, this is the powder form or solid form. So because of hygroscopic in nature, it will absorb moisture from the atmosphere and it will become liquid type. So it will not no more, it will be powder form. It will absorb moisture and it will be of no use. Then you cannot be sure that because this is absorbing. Right now you can see that this is calcium chloride plus 2H2O. This contains in the molecular formula calcium chloride plus hydrogen and oxygen, means water. Two molecules of water is also there. If you keep it open, there will be a lot of water coming here, and this is no more 2H2O. This may be 7H2O, or I don't know how many H2O is there. That you cannot calculate. So you will not be able to know the molecular weight, and then you cannot make solution of your desired molarity. So this is still packed. If you open it, you have to keep it tightly closed, otherwise it will absorb moisture. So all these information can be obtained from the material safety data sheet, and accordingly you have to use. You can see this is the spatula. Okay, this is made of steel and this is made of plastic. Okay, so whatever is available, whatever the purpose, so this we can say this can be disposable, but this can be reused, but this is always reusable. You use it, then wash it or clean it, and then it can be reused. Of course this can also be reused, but you have to see that what type of chemical you are going to use. So depending on the availability, you have to use it. There are certain chemicals which may react with, of course this is made of stainless steel and this is made of plastic. So some chemical where metal should not be used, you can use plastic. Somewhere you will find that this plastic will be getting dissolved or will be of no use, or this will be destroyed. Then you have to use this steel or stainless steel spatula. So you can see this is something like a spoon and this is something like knife, or you can say flat things. So depending on the requirement, either you can use this way or you can use this way. This is called a spatula. Okay, so while handling chemicals, not all the chemicals are as safe as calcium chloride or maybe ammonium sulfate. So there are certain chemicals which are not good enough to be used by naked hand. Okay, so in that case, you should use gloves. Hmm? You should use gloves to handle that. So you can see this is the gloves box, and you can see here it is written what is this is written M. Okay, so this indicates that the size of the gloves is medium. If it is written L, then this is large size glove. If here it is written S, means a small size. So depending on size of your palm, you have to find out whether large size gloves will be suitable for your hand, a smaller size or medium size. For me, medium size gloves are fitting, so I am going to use these gloves. Okay, and then you can see these are the gloves put in the box, medium size is written. So accordingly you have to um, select the gloves and then use it. If I use a small size gloves, that will not be fitting. If I use large size gloves, it will be too loose in my hand, and it will be difficult for me to work wearing that sort of gloves. So let me see. So this is powder free gloves, means there is no powder inside, but while wearing the gloves you have to make it sure that your hands are not wet. गीला नहीं है. It should not be wet, it should be dry. Okay, so my hand is dry, I will try to wear the gloves. See, so all the four fingers has gone in the place, and then I will try to wear like this. You can see fitting well, and just if I do like this, this is fitting well. So one hand glove is okay. Now I will try second hand. So again I am putting here all the fingers coming here, and then I will try to, and then like this. So gloves are fitting here. You can see of course I am wearing this rings, so that is why some obstructions are there. So like fitting well. If a smaller size is there, it will be too tight, I cannot work, I cannot do like this. Okay, of if I use large size, it will be too loose, and if I many wrinkles and things will be there, so it will be difficult for me to handle anything. So this is fitting gloves, and then I will start working. So if I start handling some hazardous chemicals, so all those chemicals will be sticking on this. Now, after working, I have to remove the gloves. Then only I can do something, no? Because these gloves outside is full of, say, for ethidium bromide. Ethidium bromide is carcinogenic chemical which is used when we use agarose gel electrophoresis. When we run agarose gel loaded with DNA, RNA to visualize that, we used to add ethidium bromide. So ethidium bromide go and intercalate between strands of DNA, and then if you observe it under UV light, then you can see the band. Actually, we are not visualizing the DNA, but we are visualizing the presence of ethidium bromide, because ethidium bromide starts glowing under UV light. So wherever ethidium bromide is there, why it is there? Because it is intercalated with DNA or RNA. So if you are able to see the ethidium bromide, means DNA and RNA is there. And depending on the amount of DNA or RNA, the amount of ethidium bromide will be collected there. So more ethidium bromide intensity you are seeing, means more DNA is there. So in that way, linear relationship is there. More ethidium bromide you are able to see, means more DNA is there. Or you can say, because there more DNA was there. That is why it has collected more ethidium bromide. So I am able to see more glow there under UV light. So after doing all these things, this is full of ethidium bromide, and I said ethidium bromide is carcinogenic in nature, so that should not come in contact of my hands, my skin. I should not eat somehow ethidium bromide, otherwise all sort of cancer will be there. Okay, so I have to avoid touching ethidium bromide. And now, since I have been working, just for example, I have been working with ethidium bromide, so this is full of ethidium bromide. Now I want to remove it. So how to remove? If I remove somehow one gloves and then I just try to pull this, then this you are going to touch directly ethylene bromide. So I am trying to tell you that now I will show how to remove ethidium bromide contaminated gloves from your hand. Okay, simply what you have to do, you have to hold this one. You are not going to hold your skin, you are holding this gloves and you are removing like this. It has come out. Okay, and now you have to say, for example, below there is dustbin, you are dropping here, so that will go to the dustbin. Now you can see that my hand is not having gloves. Now if I remove this, then I am going to touch the ethidium bromide, because this is full of ethidium bromide. So I don't have to do again whatever I have done last time, that I will not do. No, I don't have to do this one. What I will do now, now I am going here, because ethidium bromide may be here, maybe here, but not here. So I am trying to put hands like this and remove this. Okay, so like that, and you drop it to the dustbin. So remove without touching outer side of the gloves. I have removed the gloves. Otherwise there is no use of wearing gloves if you are removing like this and like this, means touching ethidium bromide. Okay, so while showing you the tips, no, see, this is again a tip which is similar to yellow tips. Of course, this is not yellow, white in color. But are you able to see something here? Some white material. So this is filter. Okay. So this tips is called filter tips. Okay. So whenever we are using, we are afraid that some contamination should come inside that pipette, then we use this filter tips, or maybe microbial culture or something we are using, and those microbes should not go inside the pipettes. Otherwise microbes going inside the pipette, say for example, if you are handling Bacillus thuringiensis solution with the pipette, and your pipette contains lot of Bacillus thuringiensis. So your pipette is contaminated with that. And next time you are going to use E. coli for molecular biology work. So while working with E. coli, Bacillus thuringiensis is already, yeah, amoeba or some type of microbes is already there in your pipette. So whatever microbial culture you are going to use or handle, that will not be pure culture. That will be mixing of different types of microbes. So in that case, to avoid such contamination, maybe the bacterial contamination or maybe some aerosol contamination or whatever it may be, we use filter tips. So this filter will not allow anything to go inside beyond this filter and into your pipette. So your pipettes will be contamination free, either chemical contamination or microbial contamination. So in that case, we use filter tips. So this filter tips, this is 200 microliter capacity tips. So 1 ml tips is also coming, but you have to go for filter tips, smaller tips or bigger tips. Okay, so now we will try to see some of the equipments. Have you ever seen what is this one? Do you know? So if you see it, you will find that color scale, something written here. So this is pH paper. So using this pH paper, you can determine what is the pH of solution. And then if you dip into the solution, the paper here, this is of course a stack of paper. So we can remove one to show you. So now you can see this is that, and you can see stack of papers. So you have to remove one paper here, one strip, tear it, and dip into the solution. Okay, so when you dip into the solution, depending on the pH, it will change the color. Now whatever color is there, you have to match with this chart and then find out. And this according to a color, no, that value, pH value is also written. So depending on the matching color, you can find out what is the pH of that particular solution roughly. Of course, in matching, while matching, this may, what is the color here, somebody can say this is yellow, somebody can say this is pink, somebody can say. So that is why chart is there. So you try to match it, and again matching, somebody can say, oh, matching with this, somebody can, no, matching with this, somebody can say matching with this. So that much variation may be there. So this is roughly going to give you the idea that what is the pH. And you can see this solution is, particular solution is acidic or basic, depending on. And of course, this is not the whole range of pH, only minor variation. So different range of pH paper also comes, and then you can find out this. So find out the uh, pH of that particular solution. So to be very precise, we have to use pH meter. So I am trying to show you the pH meter. So this is the pH meter, which can be used for measuring the pH, very accurately measuring pH. Okay, so this is the pH meter, and this is the power supply. For this works on electricity. Okay, and this is the main instrument, and this is the electrode of this. Okay, so you have to put this electrode into the solution, and then like this. So this electrode should go inside here, inside the solution. It will be dipping, and then you have to switch on the pH meter, and then you can see off on switch is there. And this measure is there. So if you press this button, this will take the pH meter, pH reading, and on this display you will find actually what is the pH value of this solution. So to measure the pH very accurately, you can use pH meter. So what pH meter is going to do, this electrode, there are actually two types of electrodes, reference electrodes and then measuring the pH. So compared to the reference electron, it is going to see what is the concentration of hydrogen ion in that particular solution, and then the machine is going to make the calculations. Negative logarithm of hydrogen ion concentration is called pH. Negative log of hydrogen ion concentration is the pH. So that calculation, after measuring what is the hydrogen ion concentration, it will convert it process it, because this is microprocessor based instrument. So it will convert and it will show you the pH is maybe 5.6 or maybe 5.67, two digit pH it will show. So like that, exactly the pH will be mentioned to you. But you cannot measure pH that much exactly using pH paper. That is why we require in biochemistry and in so many microbiology, biochemistry, we use pH meter instead of this pH paper. So in agronomy or roughly you want to know that yes, pH should be somewhat less, less than 7. So it should be little bit acidic in nature. So less than 7. So you can say yes, it is 5, it is 4, it is less than 7. Okay, done. Or it should be more than 7, means basic in nature. So that sort of things can be done using pH paper. But if you want that pH should be 5.2, not 5.1, then you have to, you will measure the pH, you will find that okay, it is 5. So 5 should be increased to 5.2. So what you are going to add, you will add KOH or NOH solution in that, mix it properly, and then you will measure what is the pH meter, what is the pH. Okay, so when you are going to put NaOH or KOH in the solution, it should be mixed very well. Uh, can you bring the magnetic um, this? So I will again show you. So this is a stirrer. You can see this one. This is a stirrer again working on electricity. So this will be conducted on electricity. Conducted with electricity. You have to keep the solution here, and of course, it should be opened. And you need some magnetic bits, okay, to stir it. This is magnetic stirrer, and then you require magnetic bits. So there are different size of different types of magnetic bits. You can see here that very small magnetic bit, they are all magnets. This is a small one. Hmm, you can see there are so many. This is the bigger one, biggest one. So if I put inside this bottle, this is too much, too big. So either I can put this a smaller one, or this one, or this one. These are a smaller ones. 4 bits are there. Okay. So say for example, if I put this one, can you see the bit is there? You see, this has started. Okay. Oh, no. This is acetic acid solution. Hmm. And you see the knob. So that's almost I have made you switch it off. Okay. So if I switch it on and increase little bit speed, so it will start moving, and again less speed. If I increase it, the speed will go on increasing, and if I increase more than this, then it will start bubbling. Okay. Hmm. So you can. So while adjusting the pH, it is recommended that that solution should be mixed, and then whatever NaOH or KOH you are adding, that will be mixed together, and then you can take the reading what is the pH value, and then exactly, unless you are mixing, the pH will not be adjusted accurately. So this is magnetic stirrer. You can do like that, and if you switch it off, this will stop. Okay, and now whatever bit is there sitting inside. Okay, let me show you here. See, that may start moving, little bit is moving. So that was outside the solution, I mean inside the solution, and here just I am trying to show you outside. So this will move like this, like that. Hmm. Now you imagine that this one, whatever is there inside. So this one is inside the bottle. So I cannot put my hand here and take out. If I, this solution is either, if I put my hand, this solution will be contaminated, or my hand will be uh, maybe damaged because of this solution. So, but I have to take out this bit inside here. Here, the bit is there. You can see here, this bit I have to take out. How to take out? So imagine that this is inside the bottle. Okay. So what I can do, this is one policeman. This one, this rod. Okay. And again, so I will put this rod. I will open this bottle. And I will put this rod here. See, going inside, and it will put down, and then it will. So that I am going to show you. This is acetic acid solution, so we cannot keep it open for longer time. So like that. Okay. So say for example, this is that bit, and suppose that this is inside that, this one. So you have to take out, this bottle was here. So you have to take out the bottle outside of this magnetic stirrer here, and then you have to dip this inside here. So like this, and then this magnetic bit will come out of this. So you can see sticking, because of the magnet, this magnetic bit has come out of that bottle, and then you can take it out like this. Okay, so this is something like policeman taking that magnetic bar from the solution, and then you can wash it, and what was this one magnetic bit, and then you can use it. And don't forget to wash this one, otherwise next time if we are putting this to another solution, that is going, this is going to contaminate your solution. So always you have to wash this policeman as well as this magnetic bead before reusing it, otherwise this is going to contaminate your uh, chemicals. Okay. Okay, so this magnetic stirrer is only stirring. There are magnetic stirrer which can heat as well as stir. Take out all these things and bring that one. So heating plus stirring. So there is another magnetic. No, 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 no. So this is hot plate. This is hot plate, and again you can see that this is stirring. So knob is there. So this is for heating. You increase the temperature, it will increase the temperature, and here you can see stir. So this will do stirring. You can put your bottle here and switch it on. So this will stirring. And if you don't want to heat, don't switch it on. If you want to heat, then put the heater on, or if you want to without heating you want to stir, so don't switch it heater, simply do the stirring. So hot plate with stirrer. Take this also. Vortex mixer. So sometime we need to mix the solution. So mixing can be done so this is the tube. So if some solution is there in this tube, how the mixing can be done? Mixing can be done like this. This way also we can do the mixing. But while if you do like this, something will come and sit inside this cap. Okay. So instead, I don't want to tilt this tube, but still I want to mix it. Okay. Then we use vortex mixer. So this is the vortex mixer. Okay. And you see this one. You see this starts vortexing. I have switched it on, and then if I increase the knob, so like this stirring can be done. So like this. So not only this can be stirred, but bigger tubes, say for example, uh, this one, switch it on like or this one, they can be mixed. Okay, so all that sort of stirring can be done using vortex mixer. This is called vortex mixer. Remove this one. You can bring that balance carefully. So now you can see whenever we want to measure something, no, we need a balance, weighing. Okay, so you can see this is the balance. Okay, now it is getting on. So now you can see the reading is 00. I want to see that this Eppendorf tube without containing anything, what is the weight of this. So I will open it and I will keep it here, and then you can see 1.177 gram. Okay, so that is the weight of this Eppendorf tube. And now I want to measure something, so I would like to make it 0, whatever weight of this tube is there. So you press the tear button. So now the weight of that tube is almost 0. Whatever weight was there, that is nullified. So whatever you are going to add in the tube, that will be measured. Okay, so this process is called tearing. Tear it and then weigh it. But if you want to weigh something, no, where to weigh? Either you have to put some paper or you have to put weighing board. So you can see here, this is the weighing container. Okay, so this is empty container. Hmm? The weight of that container is 3.782. Okay, so I want to tear it, means weight of that is now nullified, 0. Okay, and then now I want to put some chemical there and weigh how much is this. Suppose this is the chemical, so I am putting inside. Hmm? Now we have seen earlier that the weight of Eppendorf tube was 1.177, and exactly that one is coming. Okay, so that is how we are going to measure. And suppose no, I want 1.100, so little bit you have to take out, and for taking out you need a spatula. Okay, so you will use this spatula, you will take out things, something out, and okay, and okay, like that, until the reading coming 1.100, you will go on doing that. Okay, and see, this is the chamber, glass chamber made, so that this, while weighing, air is not going to, or if fan is running or some air is blowing, so that is not going to disturb. That is why this chamber, the whole chamber is there. You can open the chamber from here, you can reach this way. Okay, so close this one, you can open this way, you can reach here. Or these are the, you can open from this side, and if you close from all the sides, after putting the materials, close from all the sides and see the reading, so that after some time that reading will be stable, and that reading only you have to measure. So after doing all these things, my suppose my weighing and all these things are over, so I will switch off this one. I will switch off. So now the balance is switched off. You can see now it is switched off. So while doing all these things, no, I might have made dirty. So those chemicals and all these things might have been fallen here, and all the chemicals will be here. So next time if I weigh, all these things will be mixed up. So I need to clean it using this brush. So clean it, remove all the contaminating materials like this, and remove it. Okay, so this brush should be available. This weighing boards, of course, of different size, different types, they are available, so those things can be used. So now I will try to show you what is this one. This is pestle mortar. Okay, so whenever we are trying to homogenize or grind the samples or some tissue, maybe leaf tissue, root tissue, or whatever plant tissue, animal tissue, whatever things are there, we used to put inside there, and then do the grinding like this, holding and then grinding. So this is pestle and mortar made of clay china bone. China bone, that sort of things is there, and you have to, after using, you have to clean it, and depending on the experimental requirement, you may need to autoclave it so that no bacterial contamination. You can wrap it with aluminum foil, and uh, autoclave it, or if that autoclaving is not required, you can clean, but cleaning is very much required if you don't want sterilized material. So depending on the requirement, you either you have to clean it, you have to autoclave it without wrapping or with wrapping. Then sometime we use liquid nitrogen for grinding. So if you can put liquid nitrogen here, it will be too cold. So you have to uh, hold it with some insulating material and then do the grinding. Okay, so all those sort of things are there. So you have to follow precautions, and whenever you are using liquid nitrogen, you have to be very careful, because temperature of liquid nitrogen is very very less. It is minus 196 degrees centigrade. So if you touch, suppose this pestle mortar is full of liquid nitrogen, and if you put your finger inside and you just twist it, it will be powder, no more your finger. Okay, so you have to be very very careful about, and that is called cold burning. Your finger will be no more finger, it will be senseless, and anybody will twist it and it will be broken into powder. So it is so cold. So you have to try to avoid touching liquid nitrogen. Same nitrogen gas is there, but it is so cold that it has become liquid in nature, no more gas, it is liquid now. Similarly, if you are going to handle um, container containing liquid nitrogen, so that container will be too cold, so you have to use cryo gloves made of asbestos. So while using this pestle mortar containing liquid nitrogen, you have to use cryo gloves, otherwise you cannot hold. After holding only, you have to hold it, and then grinding you have to do. So like that, by one hand you have to hold this, and you have, so because this contains liquid nitrogen, so holding, if you hold like this, your hand cannot hold it for 2 3 or 4 seconds, more than 4 seconds. So you have to use cryo gloves. So similarly, if you are using dry ice, dry ice, again temperature is very very less, something around less than minus 100 degree centigrade. So you have to handle it carefully, otherwise you will have cold burning, and those things are not good for your health, not good for your body parts. They may be spoiled, your body parts may be spoiled. So whenever you are working in the laboratory, you must, okay, let me put the camera here, you must use apron, that I might have told earlier, and then you need to wear gloves according to the requirements, whatever experiment you are doing. But apron is must. You should always wear apron to protect your clothings. And sometimes if you are using UV light, you are working with UV light, then goggles should be there to protect your eyes from UV light. Generally, when we work with laminar flow, we use UV light. So you should wear gloves, goggles to protect your light. And whenever we are working in laminar flow, we never work with UV light on. We put the UV light on to decontaminate the laminar flow. So whenever you are not working, you will put the UV light on, and when you go on uh, go and start your work, you will switch off the UV light, you will switch on the daylight or visible light tube, and then you will start working. But when you are trying to see your agarose gel, then you have to put UV light on and then see your gel in the condition when UV light is on. So that time, if you are not using protective shield, then UV light will directly come to your face and damage your skin at the face, as well as it will damage your eyes. So that time you have to use face mask, at least goggles, which will protect your eyes from UV light. And but still your face skin on your face will be affected by the UV light. So we use face mask. Generally, there is one shield on the UV transilluminator which do not allow UV light to come out of the translumimeter and come to your hands, to come to your face, or come to your eyes. They are stopped there itself. So all these precautions must be taken care. So while working in the laboratory, you must always try to wear shoes, not slippers, because slippers will allow your skins to be exposed if you are doing something and then it is pouring down. So while pouring down, it will directly go and contact your feet. If it is inside the shoes, it will not directly come on your skin. If you are wearing slippers and any sort of open type of shoes, then it will directly go and touch your skin and it may damage. If your shoes are damaged, you can change your shoes. But your skins are damaged, then you have to sit in your room for maybe a few weeks or few months, unless your skin is replaced and you are getting your things are getting held up. So healing process will take time. So to avoid all these things, you have to wear shoes. That will be better, whether it is male or female. Generally female use different types of sandals and slippers. So those things are not very good practice for those girls which are who are working in the laboratory. Okay, I think we should stop here today, and then we will continue in the next class. Okay, see you again next time.